Welcome back, sixth grade. Today we're going to be working out of your book. So if you could open to page 457, please. We're going to talk about something called mean absolute deviation. And while this may sound a little confusing at first, I think you'll get the hang of it. So you will need a calculator to do some calculations with. And here we go. So there's a couple of terms here that are highlighted for you. It says a measure of variability is a single number used to describe the spread of a data set. It is also called the measure of spread. One measure of variability is called the mean absolute deviation, and it's referred to as MAD or MAD, which is the mean of the distances between the data values and the mean of the data set. It's a lot of words, I know. What's important here is this. We're looking for the mean of the distances between the data values and the mean of the entire data set. So we'll work through some examples and I think it'll make more sense. All right, so we have some data that represents the height in feet of various buildings. And from that, we're going to find the mean absolute deviation. So first thing we have to do is always calculate the mean. So let's look at the data in part A. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. All right, so we're going to calculate the mean. So with your calculator, go ahead and add up all the values and divide by 10 because there are 10 of them. Go ahead and pause the video and make that happen. So the sum of all the data values is 591. We're dividing it by 10 because there are 10 data values, and it does say here to round to the nearest whole number, so that would be approximately 59. Now, if you did not get that, go back and redo the calculation on your calculator. It's really important that you do calculations twice anyway to make sure that you get the correct answers. Okay, so that was step one, is to find the mean of the data. Now we're going to go through and we're going to compare each of the heights that we originally used in our calculation with the mean. So if the mean is 59 and the first piece of data, the height was 60, we want to just calculate the difference between them. So the difference between them is 1. Because 60 minus 59 is 1. Then we're going to do the same thing with each of these. So the difference between 59 and 58 is 1. The difference between 59 and 54 is 5. The next one is 3, and then 4. Oops, I don't know why that happened. 4, and then 6, 3, 0, 3, and 1. Okay, those are the distances from the mean. It's just how far is it from that actual height to the mean. Okay, now in order to calculate the mean absolute deviation, all we do is find the mean of these numbers. That means we're going to add these numbers up and divide them by 10. Do that now. So the sum of all those numbers is 27, and there are 10 of them. And so if we divided that, it would give us 2 7/10. But it does say here to round to the nearest whole number, so we'll say it's approximately 3. Okay, so 3 then represents the mean absolute deviation. That means on an average, each data value is about 3 from the actual mean. All right, so let's do part B, which starts on the bottom of this page and then continues on the next page. But the first thing we're going to do is calculate the mean. So here's our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. So we're going to find the sum of them, divide it by 9, and then round it to the nearest whole number. Pause the video and do that calculation, please. All right, so the sum of all the data values was 449, and you divide that by 9 because there are 9 of them, and you round the answer to the nearest whole number, which makes it approximately 50. All right, so go ahead and jump to the next page. So we have a mean of approximately 50. These are the actual data values in the chart, and we're going to calculate the difference between them. So how far is it from 46 to 50? it's 4. From 47 to 50 is 3. Difference of 6 there, 2, 4, 2, 7, 2, and 5. Okay, so now we're going to calculate the MAD, or the mean absolute deviation, by finding the mean of the differences. Go ahead and add them up, and then we'll divide that by 9. So the sum of the values was 35. We divide that by 9, and you round it to the nearest whole number, which gives you about 4. So what that means is that the average of the distances from the mean is about 4. So let's talk about this question here about the difference between the measure of center and a measure of variability. So the measure of center that we're working with today is mean. And the mean kind of tells you what the middle value is in a set of data. The measure of variability, though, if you think about the word variability, it means how much difference there is. Variability has to do with difference. So the measure of variability kind of tells you how far apart the data is, how spread out it is. So the higher the mean absolute deviation, the greater the spread of data. Okay, so look at the bottom of page 459. And we're going to work on this problem together here. Okay, so it says 2 waiters at a cafe each serve 10 large fruit smoothies. The amounts in each waiter's smoothies are shown below. So they're probably measuring, they have a scale and they want to see the weight of each smoothie when they serve it. Okay, so we want to know which waiter's smoothies showed less variability. That means less spread in how far they were from the mean. So the first step is going to be to find the mean for each set of data. Okay, so let's go ahead and do the waiter A. And you need to think about, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So we're going to find the sum of that and divide it by 10. And on the second one, we would do the same thing, the sum of all of the data and divide it by 10. Pause the video and do those calculations, please. Okay, so what you should have found is that the mean is the same for both waiters, and it is about 20, which makes it an easy number to work with. So now our job is to find the mean absolute deviation. So the way we're going to do that is we need to find how far apart each piece of data is from 20. So if you look at, and I'm going to write them down underneath in the chart. So 19 1/10 is 9/10 away from 20. 20 1/10 is 1/10 away. 9/10, 4/10, 9/10, 5/10. And obviously this can be done without a calculator because these are easy numbers to work with. This is 3/10 and this is 9/10. Okay, then we're going to add those numbers up and divide by 10 also. And you can do the same thing then with waiter B. And if it's 20, there are 2 data values there that are 20, there's no difference. So that would be a 0 for those 2. Okay, so now that you have the differences between the mean and the data values, we're going to find the average of those. So pause the video and do those calculations. Okay, so in the first set of data, if you add up all the data, all the differences, you get 6 3/10, which you divide by 10, and you get about 6/10. Okay, now in the second piece of data, I had a mistake when I did the difference on that first one. It should be 1/10. So if you add these up, you get 2 1/10, and you divide that by 10, you get approximately 2/10. So what does that mean? So we're looking for the waiter with less variability. That means there's less difference between the data values, and the mean, which is because there's less spread of data, and that would be weighter B, because 2/10 is less than 6/10. So weighter B is more consistent in getting the smoothies about the same weight. That is what that tells you. So I'm going to ask you to try page 461 on your own. I will post answers, so work the problems out and then check to see how you did. Okay, good luck.